You need the SysML v2 pilot implementation in Jupyter Lab. If you don't have a local installation, you can also use sysmlv2lab.com. The plugin ChatGPT Jupyter AI Assistant is free of charge. You can read how to install it in the installation instructions on GitHub. The plugin can also be installed as a Chrome extension via the Chrome Extension Store. After successful installation, new buttons from the plugin will appear at the top of the Jupyter Lab. In this video, we try out the explain function of the plugin. In the notebook is the textual syntax of a SysML v2 model of a drone. The model contains a geometric description of the drone, parts, time slices, a state machine, and signals, as well as use cases. If you now click on the Explain button of the plugin, you will get a natural language explanation of the model from the AI.
The given code appears to be representing a drone model in Systems Modeling Language, SysML. The breakdown of the code is as follows. The abstract part drone contains several subparts, each with its own attributes and characteristics. The shape of the drone is represented as a cylinder with a defined height, and the base shape is a circle with a specified radius. The bounding box is another attribute represented as a box with specific length, width, and height. There are time slices defined as parking and flying. This indicates different stages in which the drone can exist. For instance, while parking, it starts charging and then stops. The state part defines different states for the drone such as off, standby, charging, ready, etc. Transitions between the states based on signals are also defined. Part definitions are also present for battery, engine, and flight control. The signals define events like starting or stopping charging, switching on or off, activation or deactivation, etc. The observe area use case represents the actions performed when a drone is deployed to monitor a specific area. The drone first starts, then defines the observation area, approaches the area, flies the observation patterns, returns to the home base, and finally, the use case ends. The charge drone use case illustrates the actions related to recharging the drone's battery. The actions include starting, plugging in the drone, charging the battery, and then finishing the use case. So, SysML is a general-purpose graphical modeling language for specifying, analyzing, and verifying complex systems, which may include hardware, software, information, processes, personnel, and facilities. In this context, the code is creating a visual representation of a drone and its operation through different states, properties, and actions. However, no real execution of the code is done. It is simply a representation in the SysML modeling syntax.